Hello. Gonna do a leak code. Says keep multiplying found values by 2. You're given an array of integers nums. You're also given an integer original, which is the first number that needs to be searched for in nums. You then do the following steps. If the original is found in nums, multiply it by 2. Otherwise, stop the process. Repeat this process with the new number as long as you keep finding the number. Return the final value of original. I wonder if it has to be in a particular order. If you don't find it, then you just return the value. Okay, the constraints say 1 to 1,000. So that's interesting. So it's almost almost seems like I could use a frequency array, but so one thought I'm having is, can you sort the list? Does it have to be it's not super clear if you should start over at the beginning of the array and search the entire array again, or does it have to be in order? Neither of these examples make that clear. Let's see, are there hints? Yeah, here's some hints. And we'll find out. We'll find out as we attempt to do this. So I'm going to start by going with the assumption that you don't sort it. And I'll just like try to get it to do what it's saying there. Eyelash bug in my eye. This bug in me. Okay. Still don't think I got it. I couldn't see it. Okay. So we will okay. I'm gonna try to do a for each. So for each int num in nums, array nums if, make this condition, if num equals original, then original equals original times 2. And then I think that's it. And then you return original. So will it work? Let's find out. Nope. Okay. Oh, I see. I see a misspelling here. Got a little typo right there. Looks okay. So yeah, I mean that works. It does exactly what it says here, pretty much. So now we'll find out when I submit it whether the sorting of nums matters, or if you're just supposed to go through it as is. Okay, so here we are. Okay, 2 outputted 4, expected 16. So yeah, so it does want you to go through the whole array, like the order. You don't have to just do it in the order that nums is in. So what you're going to want to do here, this should fix it. And this would probably be the way you'd want to do it, because otherwise you would be going through the whole array multiple times. Whereas if you just sort it once at the beginning, then that's it. Okay, so what do? I think you go like arrays dot sort nums. I think that's how you write it. Okay. Yep, that's how you write it. So I remember that correctly. That should do it. Yeah. Wow. That is a slow, bad solution, apparently. But it works. So this is just doing like exactly what it was saying. You go through the nums of nums array, but if you sort it first, then it'll be in an order to where this can go through it with one pass and it'll work because it's sorted. So what could you do to make this go work better? Huh. Well, now I'm wondering what would you do to optimize this? I always like using a frequency array. But how would you use it in this case? I'm not sure. Okay, so let's think about this. Let's try to get a faster solution. This is bad on both runtime and memory. Oh, okay. I mean, you only care about the nums that are multiples of original, but I don't know how that helps you. Let's see. Jeez, I don't know. I'm sure there's some cool math trick, but I am not thinking of it. I mean, it's not obvious to me. Uh, huh. Well, all right. I'm really curious, and I don't know. So I'm going to ask Claude for a faster solution and see what the math trick is. Try to learn something here. Learn something new today. Okay. Alright. I don't know why I do this, but I just like it to be a little more sensible somehow. So I'll try that. Yeah, just today I've started noticing in Notepad they have like a spell checker thing, and that is so cool. There's been so many times that I'm like looking up how to spell something on Google so that because they didn't have it built into Notepad. But now they do, and it's pretty good. I definitely like it. Okay, Claude. Let's ask Claude. I'll do a new chat. I made this kitty kiss balloon game. It's a web browser game. I'll give Claude this question and then I'll show that to you. This was just my first pass on this. So let's see, is this gonna open in a new tab or is it gonna goof this up? I'll go over here so it doesn't. I think it opens in a new tab regardless. Yeah. Okay, so here it is. So you can grab a balloon with your mouse. And when they get close to each other, they're cats in the little basket. And when they get close enough, they give each other a kiss with little hearts. Oh gosh. And it counts the number of kitty kisses. And if they just get close enough, it'll do it. Like, I'll move this one up here now. They should get close enough when they pass by each other. Oh gosh. I'll let that go, Simon. We'll go back to this, and then we'll see how many kitty kisses it's up to. Okay. Right. Okay. Hmm. Okay. Yes, there's a much faster approach using hash set instead of sorting. Okay. Issue of your current code. Sorting takes ON login time. You iterate through all elements even though you might only need to check a few values. Optimize solution using hash set. So you add all of the interarray nums to the hash set, and then you use set contains original. While set contains original, original times equals 2. Huh. Return original. Okay. Time complexity ON, just one pass to build the set, plus at most 10 lookups since original and all values are less than or equal to 1,000. You can multiply by 2 at most about 10 times before exceeding 1,000. So yeah, space complexity ON for the hash set. Why this works better. Hash set lookups are O1 on average versus ON for searching in an array. No sorting needed. You only check the specific values you care about. original 2, original 4, etc. Given constraints, values less than 1,000 equal to 1,000. The while loop runs at most 10 times. Okay. Oh, that's pretty neat. What? So when you put it in the hash set, does it uh, does it sort it? Nah, couldn't be. I mean, maybe. But then it seems like it'd be just as fast to do that array sort if it's sorting it. Well, that's bizarre. That's a little confusing, that part. Maybe it's just saying that it contains those numbers and puts it in order so that you can see how it's finding them and stuff. But really, it's not sorted in the hash set, probably. But I don't know. I don't really know. So anyway, let's try it out. And actually, we can find out. We will find out by doing like a little write out. I forgot to put a little line in here to keep us separated. Okay. Okay. Up to 46. 7, 8. Oh gosh. Okay. Alright, let's find out. Hmm. Well, there still appears to be much faster ways to do it. I bet there's like some bit manipulation ways to do it. That's what the trick is. But yeah, that's pretty interesting. Okay, let's find out though about that. How can I find it out? Alright, let's get my AI. Ask it. Hash set, name set, set integer hash set. I'll just give it this. Not trying to go there. Trying to go there. While that's doing that, we will see if there's a faster way. see here. You just put system print out set. Order is not guaranteed. Uh-huh. So yeah, that's what I thought. I thought so. So let's just put it here. To get the bit. And let's see what happens. Huh. Well, it did put it into order. Look at that. Wow. Jeez. So that's why Claude wrote it like that, because that's what happens. Yeah, I didn't know that. I wasn't sure of it. Actually, I thought it it could be in all kinds of order, was what I thought was how that works. But it appears to be in sorted order every time with these two examples when you put it in the hash set. So that's interesting. Hmm. I might have to dig into that some more sometime. Okay, I am not going to submit that. I might go ahead and delete that so it doesn't goof something up. But I was wondering about it. Okay, well, what now? Yeah, I'll go ahead and get this, and I'll have this information if I'm ever wanting to dig into that in my notes here. Okay. What else am I trying to do? Right here. Let's see what's happening. Ooh. So that's the bit manipulation for multiplying by 2. Yeah, it's not something I'm like. You're still doing the same thing. Maybe? Bit set. New bit set. Bit set? That's crazy. Oh my gosh, what are we doing here? Great thinking, yes. There's an even faster solution using a Boolean array, which leverages the constraint that all values are less than 1,000. Optimized solution using a Boolean array. Boolean exists, new Boolean 1001 exists, num equals true for each num and nums. Oh my gosh. Huh. Well, I gotta try this out. Okay. And there's some bit thing. So yeah, that's interesting. What's going to be faster between this Boolean array and this bit manipulation stuff? Okay. Huh. That's incredible. So apparently the Boolean array is probably going to be fastest. Uh, huh, that's a neat idea. Didn't even cross my mind. Okay. Yeah. All right. All right. Let's go ahead and do the bit solution next, and then we'll do the Boolean array last. Save the best for last in this case. It only seems to go when I'm on the browser. That's what I'm noticing now. Let's watch I go back, it picks back up. Okay. Okay. Bit set. I am not aware of bit set. I don't think I've ever seen that before. Using actual bit manipulation, bit set. Java has bit set. Yeah, I don't think I've ever used bit set before or ever have seen it before. So that's new to me. I'm learning all kinds of new stuff today. But I really like that Boolean array idea because that's something that's, like it said, it's simple and fast. Okay, well, let's see how this stacks up. Ooh, 93.95, 25% memory. This might be the best performing solution using this bit set. Put the nums array into the bit set, then you original less than or equal to 1,000 and bit set dot get. Huh. Bit shift left multiply by 2, and you return the original. Okay. Alright. Yeah. Well, that's really good for sure. Okay, well, let's check the Boolean array. See how it does. %. Oh gosh. A little bit worse on memory, but 100% on running time. So yeah, it's really neat. Okay, let's dig into this. This is the most interesting solution to me. Although it's pretty similar to that bit set solution because the way it has two conditions in the while loop. But yeah, that's pretty neat. So, huh. So it is using sort of a frequency array type idea here, except the index of the Boolean array represents the numbers, is what's going on here. If the Boolean array exists, so if that number exists, then it sets it to true at that index. So yeah, so here it says exists sub original. So this is the index of exists, and they're using this condition. If that's true, if that exists, just like it says, then you multiply original times 2, and then if that exists, you do it again. As long as original is less than or equal to 1,000. All right, yeah, it's pretty neat. That's my favorite solution of this. I always like using a frequency array or using the index to represent the numbers, um, sort of like a frequency array would. I think that's pretty neat. But yeah, this is a neat new way to do that that I've never seen before or thought of. Yeah, there's so many clever things that you can do with programming. It is amazing. Wow. Like mathematics is kind of pretty interesting. All the different things you can do. But programming, it takes that to a whole nother level, I think, in a lot of ways. Oh, that is so neat. Okay. All right, well, that's it for tonight. Got, let's see, how many good solutions did we have there? If I can see it better. Okay, submissions. 1, 2, 3, 4 submissions. That's neat. So my first submission, that code that I wrote originally using arrays.sort, was 7 milliseconds runtime. And then the next one used the hash set. That was 4 milliseconds. Then the next one used bit set, and that was 1 millisecond. And then, then the next one used a Boolean array, using the index like a frequency array representing the numbers. And it's 0 milliseconds. So it's less than a millisecond, some fraction of a millisecond or something. And the memory is all pretty close, but that bit set memory is notably improved from the other ones. Well, I guess that's all I've got to say on this problem tonight. I think we really thoroughly went through this, and I learned some new things. And it was nice that I was able to write it from scratch without any AI assistance and got a completed solution. That's nice. But I didn't think of these super clever solutions, and I didn't like. I was thinking about like using a frequency array, but I would have never thought of using a Boolean array like this. And I think that's really neat. That's pretty impressive. And I really like it. I really liked yesterday's problem too, the way it would increment by one or two depending on what it started with. And I thought that was really clever. But this is really clever too. Yeah, it's really neat. Like easies can have some really neat, clever solution ideas that you might not ever think of, and and it can be something that could help you with other um, questions or puzzles or whatever. Or even if you're like, if you work at a tech place or something, some of these ideas might help you come up with some more efficient ways of doing things. Okay, well, that's it for tonight. Thanks for watching. And I really had fun playing Helldivers earlier too. We had a really good team. We were doing super hell dives. Oh, it was so fun. I barely got my 6,000 steps in before midnight though. I was having so much fun playing that. But I guess that's it for now. I might play some more hill diving tomorrow. We'll see.